Hello, so today we are going to do this problem called stamping the sequence, which is part of Leetcode daily challenge. So the problem says we have two strings. We have stamp and target. And initially we have a string s that has the same length as target, where all the string in s are question marks, right? We not filled essentially. And in this problem, in one turn, we can place a stamp over s and replace every letter with characters from that stamp. So for example, let's say the stamp is ABC and target is ABCBA, then S has the same length, so it has 5 characters with question mark initially. So let's say for the first turn at index 0, we place stamp, so we have ABC here starting from index 0. So we end up with this because we filled these 3 first one. And then we start at index 1, so here. If we place, let's say, at index 1 instead of 0, then we have ABC and the rest are question marks. If we place at index 2, yeah, same thing. So you get the idea. Now, stamp has to be fully in the boundaries of S for us to be able to stamp. So we can't place, let's say, at this index 3, for example, because then we need to place 3 characters, but we have place only for 2. So that's not a valid stamping, right? And the goal of the problem is to convert this S here with these question marks to target using at most this number of turns, right? And what we want to return is an array of the indices of the leftmost letter. So you can see here when the leftmost letter is the letter at which the index at which we started stamping. So we want to return the indices of all of those stamping starts that we did in each turn. And if we can't do it, we want to return an empty array. So that's the problem initially. Now, if we take a look at an example here with these stamp and target, so initially S is equal to this. So we can place at index 0, we'll end up with ABC at 2 question marks, and we can, after that, we can place at index 2, 0, 1, 2, so here, so we'll place ABC, and now we end up with target. So we return 0 and 2, the indices that we placed at. So that's the main problem here. We have only lowercase English letter, and the length of both stamp and target is 1000. So let's see how we can solve it. Okay, so how can we solve this? So the main thing to think about here is actually to kind of reverse thinking of the problem here. So what we get in the problem is that we have, let's say, a target string, right, with letters A, B, A, B, C, and then we have a stamp that is equal to ABC. And what we want is to fill S with 5 the same length as target, right? So the problem says go from target, fill S using stamp. But let's think about it in the reverse, right? Let's think about it starting from how many stampings can we do to get target. And so how do we do that? Well, if we can manage to just mark the places in that we would have stamped in S to get target with just star, right? So for example, in this here, first for target, let's have this here, AB, ABC, right? And let's have the result maybe somewhere below it here, right? So first we stamp ABC at index 0. So we can do this in target, our target, right? And then BC in the first pass. So we mark as 0 because we are able to stamp. And then what we do after that is we want to get BC, right? So we place here. And now we have all stars in target, which means we're able to stamp everything, so we return true. So the first part is to see, okay, if we can somehow just like mark everything to star based on this condition, we should be good. Now, to clarify here, when do we stamp? We stamp only if the letters are equal, right? So here we were able to stamp because stamp is ABC, A equal to A, right? B is equal to B. So that's why we were able to stamp. If it's different, let's say for example here, we should able to stamp only if there is a star already. And so what this would mean, I know this is confusing a little bit, but just hang on there for a moment. So what this would mean is actually it's better for us to kind of start from the end, instead of from the beginning. So basically the approach that we will do is we'll go through target, right? So we'll go through the target string A, B, C, and we'll consider each possible index, the start. Now, we know that we can't start here because stamp is of length 3, so we can't start here because we have only 2. So what this would mean is that we'll consider start from 0 to the length of the target, so length of target, minus the length of stamp plus 1, right? So that we end here when it's possible to do 3. So that's the first thing. So we'll go from each start and we'll check, can we place a stamp in this start? If we can, then what we'll do, can we place stamp, right? If we can, I will describe later how can we check that. Now, if we can, then we will replace the entire portion from start to start plus the length of stamp. We'll replace that with star to mark that we stamp it. So let's say, for example, we check here and we find that we can place it, right? Because all of them are equal. Here we can't place it here first because this A here is different. So that's the error that I made here, right? So here you can notice that we shouldn't place at ABA because it's not equal to ABC, but we can place here. So we start out here with star, and then now we have AB. So first we place at index 2, and then we come here, AB is equal, right? But then we have a star, and the star means it's okay, we can put it here because we can just think about it, okay, first we do it in the reverse, really, because we put ABC and then we'll cover it with ABC, so it still works. So any place there is a star, we can ignore it not matching the stamp, right? And so here we mark this as star, and now we did everything. Okay, I'll take another example to make sure this is clear. So let's take the second example here. Let's take it somewhere here. So where we have stamp equal to ABCA and target equal to AABCACA, right? So with this example here, let's mark our target. And these are the indices. Our indices are 0, 1, 2, 3, 4, 5, 6, 7, okay? So what we want is to check each start if we can stamp, and we are able to stamp only if we find all these letters or star in place of one of these letters, right? So we'll check, okay, can we place it in the first position, 0? No, we can't. Can we place it in the second? No, because we have AA. This one doesn't match. A here doesn't match. Can we place it from this start, index 2? A, B, C, A. Yes, right? It's possible. So we put stars where we place it, because it's all of them match, and now we have this. Okay, and now we check again another while loop, right? So basically, while everything is not star, all target are not star, keep trying every start position. Okay, so now we go again, right? Can we place it at A? No, we can't. Can we place it at this A? We can, because this A matches, and BCA we have stars. So for star, we can consider that it matches. Why is that? So why can we consider that start matches? For example, let's take this here. Why can we consider that it matches? Because we can first do this ABCA, even though it doesn't match, and then we will replace this anyway with ABCA. So, but we are doing it kind of later than we are doing it in reality, right? And that's what's marking it as star here means, is because we won't find a match anyway we found a match anyway, so we can place here whatever we want. We will override it later. So that's the main idea here. And so here we'll find, okay, it's possible because there are either stars or a match. So basically star or a match, a letter match, this is okay. This means we can proceed and mark that as a stamping. So here we have A, now star because we stamped it here. So what are our stamps at this point? So the first stamp we did, it's at index 2. The second one we did is at index 1. Okay. Okay, so now we still don't have everything as star, so we keep going again. Can we stamp at index 0? Yes, we can now because we have a match and the rest are stars. So this would mean we'll stamp at index 0, so we'll stamp here. Okay, and so now we still have letters that are not stars, so we go again. Can we stamp as 0? It's already stamped, so we can ignore everything that is already stamped. We can just keep going forward. Can we do CA? Actually, for those that are star, unless everything is a star, we can try. So here, if we look at this index here, can we stamp here? Well, these two are stars, so we can put anything we want there. For CA, that matches the end, right? So that means we can actually stamp here. Okay, so which means we can stamp at index 4. And so we do this, 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 and now we are done because everything is a star, right? So to recap, what we do is while we can update, while we can stamp, we keep going, okay? And for each thing, we check if we can stamp. And being able to stamp is either all the characters match, or the ones that are in target still characters match, and the other ones are stars. So stars, we can place everything because we can just reverse the stamping and put the one where the characters don't match but end up being star first, and then replace with the one that matches after that, right? So we can just, instead of doing 2 1 0 4, we do 4 0 1 2. So that's why for the stars we can place anything we want because we will cover them later on anyway, right? So that's the main idea here. I hope it's clear here. And then every time we found a stamp, we mark the place with stars, and then we add that to our list of result stamping, right? Yeah, I hope this is clear. Now let me just do it on the other example again to make sure it's really clear. So stamp is equal to this, and then target is equal to ABAC. ABC, right? So let's do that. So we have A, B, A, B, C, and the indices are 0, 1, 2, 3, 4, and our result of stamps is like this here. Okay, so can we stamp at 0? No, because ABA doesn't match. Can we stamp at 1? No, BAB doesn't match. Can we stamp at 2, starting at 2? ABC? Yes, because everything matches. So we add 2, and we replace with stars. Is everything star now? According to this, no. And so we proceed. Can we stamp starting at 0, AB, and then stars? We can, because A, B match, and then for the C that doesn't match, the C there is a star, right? So we do A, B. So now we can stamp at starting from 0, so we mark 0, and then we do star, and now everything is the star, so we are done. Now, we were able to do this, to mark this as a stamp, because we'll just reverse. We'll start at 0 with ABC, right? And then here there is still the old BC, and then after that we'll do AB, ABC, because we'll stamp again here, and that will cover the one that there is a problem. So if we do it, so the actual order of stamping is reversed like this, but if we take advantage of the places that are star and just consider them covered, then we can do it in the reverse order easily. I hope that that is clicking. I know it's a little bit hard to explain. Okay, so that's the main idea. Now let's just code it up and make sure it passes. Okay, let's write down the solution that we just saw in the overview. So a couple of housekeeping variables that we need. We need the length of the target, we need the length of the stamp, And to be able to reference characters from stamp and from target with target like I and stamp I, to be able to reference them and replace them with values, we need them as lists. So we'll just do that here. So replace target with its list and stamp with its list. So list of target instead of string and list of stamp. And then here we want the lengths of target and length of stamp. Okay. And we want a result where we put the stamps positions. Starting positions, right? And now, as we said, while updated, which means here while everything is not a star, so we haven't, so we were able to place stars, at least one star. So what we'll do in that case is we will first mark updated equal to false, so that if we update, we mark it, and then if we don't update, it's not marked, and we can exit the loop, right? And now we will consider every start position in the range of target length minus, as we said, we want to try every possible start, except like if there are only 2 characters left, we can't stamp with 3, so we don't want to consider that. So stamp length, that's what we are doing with this here, +1. And here we'll do the logic of checking can be stamped. Check can be stamped plus replace with stars. So this is the logic that we'll do here. Now, I want to place what should we return. So we said that in the stamping, we'll get them in the reverse order. So what you want is to return them in the reverse order. But only if we place it every stamp, so which means everything is a star. So that's what we said. So when is everything a star? If the set of characters in target, they are all stars. So basically it should be equal to the set of just 1 star, right? Because we know we were able to stamp everything if we end up with target being just these, right? So which means that if we convert it to a set, we'll end up with just a set of 1 star. And so that's what I'm checking here. Otherwise, if we weren't able to replace everything, which means stamp everything, we want to return an empty list. That's what the problem says. Okay, and now we'll check if we can stamp at this position, can be stamped at this position, starting from start position. And we'll have a helper function that does that for us. So we'll give it just the start position. And if we can stamp, what should we do? We will need to replace, right, from start to start plus the stamp length, right? Because we can stamp starting at that position with, so we will replace all of these with star. That's literally what we did in the description, in the overview. And so to do that, we'll just say target from start to start plus the length of stamp is going to be all stars. So it's just star. How many times? The stamp length. So let's say stamp length is 3. This would just be 3 stars. If it was 4, this would be 4 stars, right? That's exactly what we want. So we replace with all stars in the position where we can stamp. And here, since we are able to stamp, we need to place that index in res, right? So that we can return it. So we append the start position. Okay. And we need to mark that we updated so that we can continue to the next iteration. Because if we do an iteration and we are not able to place any stamp, we are done, and so we exit. But here we don't want to be done yet because we just were able to update. And so we'll say updated equal to true. Okay. And now let's write this this stamping function here. So let's write it here. Give it a start position. So what do? Well, we want to go through stamp length. So we want to check each character, either it's equal or it's a star. Then we can continue looking until we reach the end, and we didn't find a letter that is different than star and different than the character in target. if we find that, then that means we can't stamp, right? And so we will do in j in the range of stamp length. So if the character in target at this position, so start, and then at this position where we are looking for the stamp, if it's equal to star, then we can place anything we want, as we said, right? Because then if we do the stamping in reverse order, we will just override it, right? So if it is equal to target, equal to star, then we can continue because we are good here. But if it's different, let's say we have maybe, we are trying to place maybe K, A, B, C, right? And the stamp is like, our stamp is like maybe K, B, A or something like that. So this is our target, right? So if we are looking at A and K are different, there is no need to proceed because we can't stamp because this is A and this is K. We can't stamp. And so that's what, or if we are looking, let's say maybe here, K and A, we can't stamp here because this is, let's just make this KBA so that this is actually realistic. So if this is K and this is A, we can't stamp either, right? And let's say we have here C, B different than C, we can't stamp. So if this is different than the stamp at position J, that's exactly what I'm doing here, then we are done. We can return false because we can stamp. Okay? But if we are here, this means that there is a match. So maybe we have A, B. So B, but maybe C here. We don't care. But let's say B and B, there is a match, right? So we can continue because maybe we have a stamp. So we can continue here. So here that means letters at this position are same. That means potentially we can stamp. So let's actually have a variable here, call it stamping possible, that starts out at false. Okay, so let's say stamping possible equal to true. Okay, and then at the end here we return stamping possible. Okay, so here this are the same, so potentially there is a possible stamping, right? You may say, why not just return true here, right? You may say, why not return true here? Because what if we have, so if we have ABK, return true here works, but what if we have C here? Then if we go to G equal to 3, equal to 2, we will find that K and C are different, and so we'll end up here, we'll return false. So we want that to happen, right? So that's why we just mark it as true. It's potentially stamping possible, so that if all the next times we end up not finding this, right, then we return, we will return true, right? And if all of them are star, we'll return false because there is nothing to stamp. But if some of them are star, let's say we have maybe star, star here, we already filled something, and then we have C here, right? So we'll find, okay, all of them stars, so we continue, and then we will end up with the else here because letters are the same. So actually here we can also do else if you like. All of them the same, and so we'll mark it as true and we'll return true. And similar thing, if we have A, B star, we'll find that, okay, the first one matches, and so we'll put true, maybe even we have 2 star. The first one matches, so I'll put true, and then the other ones will continue, and then at the end we'll return true, right? So that's why we'll do this here. And that's pretty much it. So the only thing we want to do is initialize updated before the while loop. And for the while loop to enter the first time, we need to initialize it to true. And that's pretty much it. So let's run this. So the main idea here is doing it in the reverse and using the stars on target. Those are the two main ideas. Let's submit. Okay, so that passes test cases. Yeah, so that's pretty much it, I think, for this problem. Please like and subscribe, and see you on the next one. Bye.